Hi everybody, my name is Aníbal Tavares Azevedo, and now we're gonna continue the series of videos about how we can use a new artificial intelligence technique in supply chain. So this video will be a lot of more about detailed implementation. We have some general guidelines that will be explained in this video. So this video will be important to make the Python programs and to make this in a very well structured way. So let's see the presentation here. So we're gonna use this artificial intelligence technique in supply chain. This is the first track. This is the first class of this track, and I will give you in this first class an overview about what will be done in this track. So first, let's see the marine traffic here. This is a very important picture because tell us our problem, our supply chain product must consider an important feature, which is ports. We have here many ports. We have ports here, here, here. So as you can see, an important entity is port. Here we have a picture of a port, Los Angeles port, and we have here a map here, a figure here, which we can see the ships and the port, and many ships waiting to get in on port, to get it loaded or unloaded. So here we have more details about the port. Here we have some uh, ships in the berths. Here another ship here, another ship here, and as you can see, for each ship here we need some quay cranes to operate in the ship to move or to put cargo or to move cargo to load or unload containers. Also, we have here the yard, and we have many equipments here to move the containers in the port yard. Also, we can have some trucks here. It's very difficult to see in this picture, but it's okay. So what we're gonna model here, we have this interesting mapping of what we have physically. We have the yard where we have some containers that should be loaded to the ship, and in the ship we have some containers that should be unloaded from the ship to yard. Okay, so the yard in this track we will consider in a very simple way. We just consider for each port we have just this number. So in this transportation matrix, we a very simplified way to represent each port. For the first port here, we have just the number of containers and the destinations of this number of containers. So two containers should be unloaded at port 2. Their destination are the port 2. For containers, the destination are is port 3 and 5 for port 4 and 0 for port 5. So using this number of containers, we're gonna get this occupation matrix. Occupation matrix is another manner to represent a container ship. So for the container ship, we're gonna get this kind of 3D matrix, and for the port yard, for each port, we're gonna consider as this transportation matrix. So I gonna use the description in this video. We'll have the PDF of this presentation, which you can download and or see in more detail or read as you think it's okay or interesting to do it. So the container ship representation will be important to see containers per bay. So imagine each bay of the container ship. Here we have in this picture these layers. So we have bay, one bay here, another bay here, another bay here. Okay. So we must have a class that represent a container ship, and what are the informations that this class should use. So here we have the fields of this class, which are a matrix here, a 3D matrix, and the first parameter is the number of bays. The second parameter is the number of lines, and the third will be the number of columns. And the second field here will be a kind of a dictionary which map the numbers, integer numbers, to colors. So the key value, the key of this dictionary, the keys of this dictionary are the keys are integer numbers, and the values of for each key will be the colors that will be related for each number. So, for example, imagine this container ship here. We can have one as a grid here. We can fill this grid with integer number, and then we can translate using this dictionary the numbers in colors, so we can fastly see what's going on or how is the occupation of the container ship in a visual way. So additionally, what we're gonna have here are the methods or the functions that will be applied to the information inside the fields. So here we have set cargo map, which will be the numbers or the cargo that will be filled in each grid in each bay. Okay. Okay, this is will be more explained in details when we perform the implementation of this class. Second, we have the set color map. Set color map is just a kind of this dictionary, so we can use many different kinds of dictionaries, and this functions just for this to change the map or the color map, and to get I don't know kind of colors for each number of integer number we have in the container ship. Also, this set ship color map perform calls these two functions. Okay. Finally, this function empty will put 0 for every grid space here. For example, this empty space is represented by 0. If you want to represent some forbidden place, we can use a -1. Okay. Here we will not perform these forbidden places to make this irregular shape, but we can use this trick to get this kind of irregular shapes. Okay, not a perfect grid here in terms of a rectangular grid. So you have some forbidden places here. We can use -1 for these forbidden places. Okay, and finally we have this function, which is just a kind of picture of container ship, a easy way to see and fast way to see how is filled the container ship. Finally, here we have some picture that will be done using Python. This picture was done using Python, so we can draw each bay. And what's important here to perform? We have to perform a simulation using loading rules and unloading rules. For example, as the ship arrived in the port, we need to remove the containers from the container ship, so we have to perform first the unloading rules. How we can unload in this ship? We have to move these containers from the ship to yard. Okay, and after this, we should do the loading operation. So we apply some loading rules or one loading rule to put some containers inside the container ship. So this set of loading and unloading rules will be explained in detail, but what is interesting to say at this moment is that we get different kind of loading rules, how to occupy the container ship, how to put containers inside the container ship can have a great variation. For example, here we have some objective here to minimize the number of movements, and here this second visualization here is when we are trying to minimize the instability measure, the instability of the container ship. Also, we can perform a small set of unloading rules, how to remove containers from the container ship, and this will be a very small set since we don't have too much possibilities here. Okay. Also, we have to when we construct the rules, we have to get this in mind. We have to fulfill these two constraints. First, the first constraint will be one cargo for each space. So we can have this mass, two containers occupying the same space at the same time. And also, we can allow these floating containers. This container doesn't have a support, and this is not a valid position that this container could occupy. So the loading rules or will be constructed observing these two constraints, okay? So here we have some kind of coding. We will do this in detail. Don't worry about this. We will have specific videos for each rule, and we will explain this code during the track. So we will start very, very, very simple. And as we advance during the track, this will be more clear how we can construct this kind of rules, loading rules here, and how we can integrate three things here. And what's important here, we have to consider the container ship. So we have to consider the container ship, the loading and unloading rules, and also we have to consider how the ships are moving the ports, which rules, unloading and loading rules are applied for each port. So this will be our simulation. And as you can see here, we have some parameters. I will explain in detail each parameter when we get in the simulation, in the simulation classes. But what we can see here is that we have the P letter here representing the port P, and we have here the transportation matrix, which give us the description of how much containers will be loaded for the container ship for certain ports. And also we have how to unload the containers from the container ship. This letter here, B, represents the container ship matrix. Let's see again. So we have the occupation matrix B. This is the occupation matrix B. This is the transportation matrix T. And so these two letters are very important here. And we will compute the total number of movements to perform some unloading operations and also for loading operations. Here we can have a second layer of the simulation that will be not addressed at this moment in this first track, but when we finish the unloading and loading operations, we can add to to this first track the total time, the computation of the total time using quake cranes. So we will need a simulation that computes this for the quake cranes, okay? Okay, so let's see again what we have. So we have a chain of rules, because for each port we have to apply some loading or unloading and loading rules. and for each port, we have these operations of loading and unloading rules for the ship. Okay, so how we gonna represent the sequence of rules that will be applied for a port? We just need a list or a vector. This vector will have a compact representation of what rule will be applied in each port. So here, for example, imagine that we are in port 1, we need to apply rule 3. So rule 3, what gonna be rule 3? Will be the loading rule 1, okay? And after this, we move to port 2. In port 2, we're gonna apply unloading rule 1 and loading rule 1, okay? And finally, when we get in port 3, we should use the loading and unloading rules, and we have a kind of decoding process here. We're gonna explore later in details how this decoding process can be done, because here we have a number, and here we have this translation in terms of numbers and letters. And this is a very interesting trick, and I will explain later in this track, okay? So we should consider all ports. So we have to pass the container ship through ports, and we should have this in detail here, how we can apply the rules. So instead of using many words here, so for example, imagine that we have unloading rule, we have some retrieving rules for the yard storage, or loading rules for the container ship, or have many rules for any equipment in the port. So to do this, we don't specify to do the vector these very complicated words. We just use a number. For example, you use number 2, and we decode this number 2 in terms of rules for the equipments considered in the for the port 1, or we can decode for this number also for port 2, okay? So this will be more clear when we implement in Python all this subject. Okay, so we're gonna need here a CS simulation class, so a container ship simulation class, okay? This CS simulation, what are the field of this simulation class? We have a symparam, which will be a T, a container ship object, and any rules information, the number of rules that we will have. And this is a kind of parameter that will give us a kind of report of what's happening inside the simulation, okay? We have this method, empty ship, which obviously clear the cargo inside the container ship. We have this method combine that uses when we unload the cargo from the container ship, we have to reload some cargo to the container ship, so in some situations. So this combine the cargo that will be unloaded from the ship and must be loaded again, plus the cargo that are already in the yard of this port. Okay, this will be a very interesting and trick method which transforms the one number, integer number, in terms of rules, in terms of numbers and words. And finally, we have this method which we give a vector, and this simulate in terms of number of movements, considering loading and unloading rules applied in a ship through ports, okay? And here, this T matrix here just this transportation matrix, which we already see in this class. So another important and interesting thing is that we should have also many combinations here. Let's see. For example, we tried this combination 3 4 2, but we can get 2 1 and 3, or 4 4 4, or 3 3 2 3. And as we can see here, we can imagine that each line is a kind an individual. It's a kind of individual that represents a possible solution to apply a behavior for the ship through ports. So what we can get, we can get many individuals, okay? We can randomly generate these individuals, and finally, we can, for each individual, we can apply a simulation. So finally, we get this. We evaluate these individuals, and for stop criteria, we can use the number of generations of generation cycles. For example, we can use this 1,000 of generations. Okay. So what is a generation cycle? We can have reproduction, this individual and this individual. We can add, we can, this is the just a combination. We can combine them. And finally, we can get a new individual. Okay, this is called reproduction. So they can get some new individuals from using some information from parental individuals. Finally, we have the crossover. We can here we have some head, and finally the blue arms here, for example, to represent this. We can just not generate new individuals, but we can combine previous individuals. By using this, we can get new individuals. So the reproduction we can see in these two ways. We can have combinations, a crossover here, and we have mutation. So an individual can change a little part randomly, okay? And this is the mutation. And this generation cycle, we can get a new population, evaluate them, these new individuals and this new population, and finally, we can perform a new generation cycle or not. And when we reach the total number of generations, we stop it, this process, and finally we get which are the best through these cycles, and we can get the best solution, a best solution, than the initial ones that we started with. So this is the all this is explained in terms of words here. We have the pictures, but the words are very important to know, which is called the genetic algorithm flowchart. I will not enter at this time in deep about this genetic algorithm, but what is important here is to know that we can get an initial randomly vector, and we can improve this. We can improve observing this kind of flowchart, applying this kind of flowchart algorithm. Here we have another vision. We are not using a genetic algorithm in using binary coding or integer coding. We are applying an integer coding, but a special integer coding, because this integer coding can be decoded in terms of unloading, loading rules, or you can add more rules, for example, Quakerane rules, and all these rules can be used inside the simulation or used with the simulation. And finally, when we stop the simulation, we get, for example, some measures like the number of movements or total time that we need to perform to load or unload some ships. Okay, so this will be the trickiest part of our program, and will be very important and interesting to get improved solutions. Finally, we have this. We can add more complexity to your program, but I think this is will be complex enough. And as you can see, the coding will be very, very simple in Python. So we have the mission here to take this all this and code in Python. So in the first track, we will explain everything in detail. So if you like this video, please make some okay for me in in this video, or if you have any doubt, please comment this video also. And in the next classes, I hope the classes will be very, very, very small. This class get too much big, but I think it's necessary to have a greater vision of the project and to understand what we are doing for each part in each part or in each class. Okay? Thank you, people, and bye bye. See you in the next video. Bye.